Hello, it's Dumplet here. Here's an item on algebra. X, y, and z are real numbers satisfying x squared plus 4 equals y cubed plus 4x minus z cubed, y squared plus 4 equals z cubed plus 4y minus x cubed, z squared plus 4 equals x cubed plus 4z minus y cubed. Find all possible ordered pairs x, y, z. Now credits to the Indonesia Regional Math Olympiad back in 2004 for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. So there's something nice about this, and it's the fact that if we analyze this 4x, 4y, and 4z, if we put it on the other side, so let's subtract both sides in the first equation by 4x, both sides by 4y in the second equation, both sides by 4z in the third equation, I'll be reaching these three equations. And as you can see here on the right hand side, y cubed minus z cubed minus x cubed, and x cubed minus y cubed, if I add everything, it's very nice, because if I add the 3, the y cubed will cancel, the x cubed will cancel, and the z cubed will cancel. And that's something to look out for. So sometimes when you have like a system of equations, maybe adding some of the equations might be a good thing, because in this case, all the cube terms will cancel. So that's nice. At least we're simplifying stuff. And alright, so let's try to do that. Now what you notice on the left side of each equation is that all of them are perfect squares. So this is simply x minus 2 quantity squared, this is simply y minus 2 quantity squared, and this is simply z minus 2 quantity squared. So if I add the left hand side of all the equations, that's going to be equal to 0, which is the sum of the right hand side of the equations. And this is pretty nice, because if we take a look at all these terms, all of them are squared, and this is just like a degenerate circle scenario, but there are like 3 squares in this case. But since we know that a square of a real number, well, x, y, and z are real numbers, so x minus 2, y minus 2, z minus 2, they all should be real numbers. So the square of any real number is non-negative, so all of these are greater than or equal to 0. Now we can easily make the analysis that if any of these are positive, so if any of these are not equal to 0, then there is at least one of these 3 must be negative. So since the minimum possible value of the left hand side is going to be 0, then it should be the case that x minus 2 quantity squared equals 0, y minus 2 quantity squared equals 0, and z minus 2 quantity squared equals 0. When does this happen? Well, it can only happen at when x equals 2, when y equals 2, and when z equals 2. Since there's only one possible case, which is all of these 3 should be equal to 0, we have the solution, and the only solution, 2, 2, 2. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!